Thank you, Alexandra. So hello, everyone. I'm Angira. I'm a research associate at the Department of Computer Science at Oxford. And I'm going to talk about a joint project with the Cambridge team, including Alexandra G. and Edward. And at Oxford, we're doing it with Annie Kalinescu and myself. The project is based on creating a digital twin for supply chain. And I'm going to go quickly over what a digital twin is. Then I'm going to talk about our literature review paper, which we researched and what were our insights and learnings from them. Then I'm going to discuss about some solutions that we are trying to work on right now based on the gaps which are present in the current research and industrial works. And moving on, we're going to talk about the data and the data analysis we've done with the data we've received from our industrial partner, which is an oil and gas field company, followed by how we're going to use this analysis into integrating it with our inventory model as the project is about supply chains. So let's get started. So a digital twin is basically a digital replica of a physical prototype. And this physical prototype could either be a car or a manufacturing unit of a car. So it could either be a product or a product lifecycle. And the components which differentiate a digital twin from some of its subset technologies like simulation system or autonomous systems is that it is supposed to have IoT components to gather data and also to perform a two-way synchronization with its physical prototype. Because without it, with this synchronization, it's not going to be a replica all the time. And there are a bunch of other components which might or might not be included in the research works or the industrial works. And there's a bit of debate going on in what the definition of a digital twin is supposed to be. And I'm going to talk about this in the next slide. But these components, which you might or might not find in other digital twins, are machine learning, domain-specific services. So you might tailor the digital twin based on the domain, some testing facilities to find out if the digital twin is working properly or not, and some security-related services to find out whether the data is not being compromised, because in a digital twin, if you have different partners, the data might, there are security issues concerned. And digital twins are especially useful for industries where creating physical prototypes can be expensive or time consuming, or where you have to perform extensive testing, such as you have to reach temperatures high or low, which cannot be done in a lab facility. So that's where digital twins are really useful, and also for real-time monitoring and forecasting and understanding if something is going to go wrong. So because a digital twin is constantly connected with the physical prototype, you can understand it has all the data on which it can perform machine learning analytics and predict if anything might go wrong in the future and alert the partners. So that's about digital twin, and our project is about creating the digital twin for supply chain. And we conducted a digital twin review. So we reviewed 85 research and industrial works to understand the state of digital twin in different industries and the current state of the art. And there are some interesting insights we found out. So firstly, there's actually no universal consensus regarding the definition. Some digital works say that this is supposed to be included in the digital twin. Some say that this is not supposed to be included. So we analyzed all of these research works and concluded our own reference framework. And this is we're going to put the paper on archive soon, and you guys can have a look at it then. And we also found out there's a lot of domain dependency in digital twins. So if the digital twin is that of an aerospace industry, you might focus more on the prototyping part, whereas if it's of a manufacturing unit, you might focus more on the monitoring. And there are also no evaluation or error metrics defined anywhere, which are universal. So most industries talk about profits and how they might saving money, but in terms of metrics, there are none. And when it comes to scaling a digital twin to large industries, it gets complicated. And there's also the challenge of high dimensional data. And we were looking at the practical implementations to learn about how we can improve these, but actually very few practical implementations are public. And to this end, we started conducting interviews, which wasn't a plan initially. And Kate has been very helpful in conducting these interviews and reaching out to companies and arranging meetings. Thank you, Kate. And there are some insights which we're working on right now. So the first one is that the security of data is a big concern. There are many industrial partners connected, and how to share data is a concern there. And there's also the ambiguity in definition, which we also found out in our research works. So to work on these, we are looking at some solutions. So the first one is about self-evolution and real-time monitoring. So because a digital twin is supposed to be constantly updated and supposed to monitor the real-time state of the physical prototype, it needs to continuously evaluate the stream of data that it's receiving. So we are proposing a continual learning framework for this, which is a machine learning methodology to continuously update its parameter based on the data that you're receiving. And the second solution that we're looking at is for the security of the data, where we are looking at a really new topic called federated learning, which in simple terms is distributed machine learning or decentralized data. And the idea is that because we are assuming we have IoT devices, because that's what a digital twin is supposed to be. So we share only the model parameters, but not the data. And in this way, the industrial partners don't have to share the data and compromise their privacy. So that's what we're looking at right now. Now, talking a bit about the data that we've received from the industrial partner. So if you look on the utmost left side, we did receive a bunch of sheets, but out of these, only 8 are unique, and the rest of them can be summarized by these 8. And because of COVID, we did face a challenge in receiving further data from the industrial partner. And to mitigate this problem, we are working on generating hybrid data. And GANs, or generative adversarial networks, are pretty popular right now. So we're looking at that. And it also has an advantage of being differentially private. So we don't know how we're going to use it, but we're working towards that. And the idea of federated learning was quite inspired from this as well. Talking a bit about the analytics that we conducted. So we mainly use machine learning methods to identify the supply chain patterns and test analytics. We tested a bunch of classification, regression, and time series methods on the demand side to predict the demand. But because we didn't have that much data, it was only 1,000 plus records on 200 parts for 3 years. So the accuracy is not that good. And if you look at the middle chart, the green lines represent the real output, sorry, the original output, and the blue ones represent the predictions. So it's not performing that well. And if you look at the rightmost, it's a time series model. The top one doesn't present that good, and the bottom is just an example that a method works on time series data if it was presented properly. On the supply side, Kate, can I go a bit slower? I'm just worried about the time, actually.
Yes, don't worry, we've got an extra 10 minutes at the end. So.
Okay, that's fine. I was just a bit worried if I'm going over, but thank you. On the supply side, we conducted a bunch of other machine learning methods, and the target was to predict lead times and also uncertainties, and the results were slightly better because we had a bit more data here, and random forest ensembles work good in this case. And out of all the machine learning methods that we tried and analysis we've conducted, we have actually built in estimated safety stock models for this. And because we had more than 200 spare parts, we performed ABC classification to see how these spare parts can be divided into different groups and designed into different order policies to fit into different scenarios. So to this end, we've defined 3 order policies to support the agent-based model simulation. And right now we're working on the what-if scenarios. And once we have these, the next step of the project is going to be optimal modeling based on what-if scenario simulation outcomes to support the decision-making. So up till now in the project, we have looked at the current state of the art of the digital twin and are almost prepared with the inventory modeling to include this in the supply chain model. And once we have this, we're going to integrate it together to build this digital twin prototype and show a proof of concept. So that's about it. Thank you.
Thank you very much, Angira. Any questions to Angira?
I have a comment, Alex.
Yeah, please go ahead.
Yeah, thanks for your talk, Angira. I'm glad you mentioned updating and synchronization, because I used to work for a simulation company. We did simulation software for nuclear power stations. Value was at about £6 million, so they're very complex models. And we never talked about digital twins, and I hear a lot of people talking about simulations as if they were digital twins, and they miss out the element that you mentioned about the synchronization and the constant updating. So thank you for that. And I'm guessing when you were looking at your definition, would I be right in thinking that a lot of people do exactly what I've just described? They talk about simulations and describe them as digital twins, which I think is part of the confusion.
That's right, David. A lot of works, I mean, like a bit of works did just say they performed a simulation and said that this is our digital twin. And we've talked about this extensively in our paper, which is going to be out soon. And that's absolutely right. Or be it some kind of agent-based simulation, they actually term it as a digital twin and do not use the current IoT devices synchronization or machine learning or big data into it. So that's right. Yeah.
Excellent. Thank you for that clarification. Look forward to seeing your paper.
Sure. Thanks.
Thank you.
Angira, I think we have 2 more comments. One, oh, we are getting a few more. Just give me a second. From Jorge. Jorge, do you want to ask your question, or I could read it out otherwise? Where does the quality? Yeah, go ahead.
Actually, it's more than one question in one. First of all, is where the data quality will sit in your framework, because if you're going to be feeding more and more data into your model, it can be affected by poor data quality that you're feeding into it.
Yeah, absolutely. That's a very interesting insight, actually. That's why we are also looking at robustness into digital twins. So for example, if something incorrect is fed to a digital twin, we want the model to find out in some way that something is going on wrong. And we don't have a model for this yet, but that is something we have included in the paper and in our framework of robustness models. But you're absolutely right. If the digital twin is going to get more and more data, at some point it has to decide about the quality and decide whether it wants to accept the data or not.
Yeah, and actually, thanks for the reply. The other question was around, would you consider, different times of the year will come with different demand rates, right? Like there's going to be obviously, and there's one coming at the end of this month, is shopping festivals, or what we call shopping festivals, right? Where the demand drastically changes and possibly the warehouses will behave much different than normal. Does your model account for that? And how do you get the specific SKUs to be discounted in your model to be considered?
So I think, Chi, would you want to take that question? Because actually, G has worked mostly on the data analytics and modeling part. So.
Yeah, Sir Josh. Actually, we already have a talk about this last time. Yeah, actually, we did not consider that as your question. So no, actually, we do not consider the shopping festival to account for the in-house stock, because our collaborator is a oil field service company, so their demand is based on the maintenance or new requirement for this spare parts. So this is not related to, it's not similar with your project for the goods or something, the demand from the shop or the shopping activities. Yeah.
Mm. So the demand in our case, I think, is not also IoT related data. So it's just, it was in general, in terms of any digital twin, it will be as good as the data it gets, as, Angira mentioned earlier. With, spikes in demand, if they are expected, such as shopping festival, and we had historical data on that, then the model might be able to handle it. But if it is, COVID lockdown, then probably not.
Yeah. So I'm just making this comment because in the previous project I worked in Dashlog, we were considering these spikes on demand, and we went for actually different models to account for different times of the year. So we'll have a normal situation, which is probably what you've been working more on, and then this shopping festival, these different sales happening all around the year, and we made kind of a switching between them in appropriate times.
if I may also add, so I think that the machine learning feature of the digital twin would perhaps differentiate between the short-term behavior and learning patterns through, so for example, capturing like shopping festivals, and in the sort of perhaps the holistic style, the digital twin should have the ability to learn in the short term, but also have the meta layer of understanding of the overall system behavior and continuous learning. But so this project is more about the proof of concept. So I think we are trying to progress with the concept and questioning the current state of the art and what was said, like there is a misperception that digital twin is just simulation, and trying to integrate to look at the sort of its potential and also its adaptability depending on the problem domain, as Angira has mentioned. So it's but the current COVID situation had a major impact on the project, sadly.
Yeah, all of us. Right, sorry for taking so much time.
No, thank you for the question. Thank you,
This
Angira.
is the aim of the webinar. So so actually on that front, on the learning front, I believe John has a comment around split learning. John, do you want to say something around that?
Yes, to say I quite like the idea of actually using the distributed machine learning approaches, which are in some way confidentiality or privacy enhancing, which is what the basis of some of this is. This finds lots of applications elsewhere, and in particular for us, it finds application in energy networks where you've got consumers and producers and things like this. So we're about to look at split learning, which is sort of a variant, I suppose, of the federated learning approach. But I think there's lots of applications of it, and this sort of is related to the question I posed earlier, which is what are the effects on constraints of information flow between the stakeholders who actually want to maintain or converge on optimality of processes if you don't trust each other. And I think that's where this sort of thing actually can be particularly useful. So I think you're doing some really good stuff, and it's really interesting. So carry on, I think is what I said.
Thank you, John. I think it will be great to have also individual chats later on, as there are many I think interesting ideas floating around that we can learn from each other. All right, so if there are no more questions to Angira,
there's one by Song on federated learning. Do you want me to take that, or should I just answer in the chat?
No, go ahead, Angira.
Song is asking about the federated learning method and what kind of devices are running the distributed model. So Song, thanks for the question. And right now we are still looking on how to include this with our project. And the idea we have currently is that we would use IoT devices, which would be based in the supply chain network to do the federated learning for us. But it's still, we're still reading on it, and we still don't have the specifics yet. So I'm sorry, I can't say more about that one.